All right, guys, welcome back to Ionic Bonding. Okay, I'm going to try to do this while I'm watching Law and Order SVU in the background. So if you guys hear some great Olivia Benson stuff, that is probably why. But, anyways, today what we're going to be doing is we're going to be building off of what we learned last week with basic ionic bonding, but today we're going to add in transition metals. All right, so we have two objectives that we're going to be doing today. You're going to be able to name ionic compounds that have transition metals in them, and we're going to be using the appropriate Roman numerals to do that. And then you're going to be able to determine the charge of a transition metal from the name, okay, and predicting the formula that way. All right, so pretty much what we were doing last week with naming and predicting formulas, but now we're gonna add in some more elements. All right, so you guys have learned that transition metals are your metals in groups 13 through, or group 3 through 12, sorry, right? And we have learned that they vary with their ion charges because they vary with their number of valence electrons. All right. And so how we can differentiate between the different types of ions is they have Roman numerals in their names. All right. So for example, here you see we have cobalt with the Roman numeral 2, chloride. That means that this sample of cobalt has a charge of +2. Okay. Remember that all transition elements, right, are metals, and all metals are cations. So it's always going to be a positive and then a number, right? And so just a quick reminder of Roman numerals. We started looking at these when we were listing our group numbers back in Unit 2, right? So we're going to be looking at Roman numerals. Wow, I can't talk. Happy Sunday. Roman numerals 1 through 6, right? So if I see just a 1 here, I know it's 1. Roman numeral 2, Roman numeral 3, 4, 5, and 6. Okay, so these are going to come into play when we are naming our transition metals. All right. So let's look at how we can take a name and create my formula. Okay. So when an ionic bond has a transition metal, okay, we follow the same exact rules that we did last week, right? We're breaking the name into my cation, my anion, with their charges, and then I'm going to swap, drop, and chop. All right. So let's go back to this, right? We've already seen cobalt to chloride, right? And so what I do is I write out my cation and my anion with its charges first, right? And so in this case, cobalt has my Roman numeral 2. So that's telling me, first off, I know it's a metal, so it's a plus, and the 2 tells me it's a +2. So I have cobalt 2+. I know chloride, all of my anions have an IDE ending, right? And so if I look at my IDE help column in your ionic bonding basic notes, right? Chloride is the same as my chlorine element. Chlorine is in group 17, so it must have a -1 charge, right? From there, all I do is I swap, drop, and chop, right? So the 2 here on cobalt gets dropped down here to chlorine. The -1 here gets dropped down to cobalt, right? So I have CO1, Cl2. And I can drop the charge at this stage, right? So I don't need the plus and the minus anymore, okay? Then my chop part is I reduce, right? We said I don't need to ever put a 1, so I can chop that out, and then the rest of it I can't simplify. So my final answer for cobalt 2 chloride is COCl2. All right. Let's look at the next one. We have tin 4 oxide. Okay. So just like we did in the past example, tin 4, right? That Roman numeral 4 tells me that I'm going to have a 4 with a plus, right? So a +4 charge, right? Always metals are positive, and that Roman numeral tells me the number, right? So my tin is SN4+, and then I have oxide, which is the same as the element oxygen. Oxygen is in group 16, so I have a -2 charge. So I have SN4+, O2-, right? So now I can go through step 2, swap, drop, and chopping. Okay, so swap, drop, and chop, right? The 4 swaps over to here, the 2 swaps over to here, and I can drop my sign at the same time. So I have SN2O4. And just as we saw with last week, I can also simplify it, right? We said that if my numbers are a common factor, right, I can simplify it out, right? So both of them have a common factor of 2, so I can divide both by 2. And my final answer is SNO2. Okay, so that would be my formula for the name tin 4 oxide, right? Take a break, pause the video, and complete these 2 practice problems in your notes. All right, welcome back. So now that we know how to take a name and go to my formula, which is like super easy, it's literally everything we've done last week except for the addition of the Roman numeral, and that literally just tells me my charge. It's in the name itself, right? We're now going to look at the reverse. So if I'm giving you the formula, so the letters and the numbers, and I want to write a name, okay? If a compound contains a transition metal or the metal, lead, or tin, those are technically not in 3 through 12. They're in my like 13 through 15, okay? They're still considered transition metals. You have to identify the charge with a Roman numeral in its name, right? Similar to how we saw it in the name itself, the charge was a Roman numeral. We have to do that with any transition metal, right? And it's tricky because transition metals, their charges can change, meaning I could have a copper 1 or I could have a copper 2, okay? So I have to be super specific about the charge that it is, okay? But we have to know certain things that are true, right? We learned that the entire compound has to have an overall charge of 0. It has to be neutral. So my charges have to cancel out, right? And I will always know the charge of my anion because those charges are not going to change, right? I know every time I have oxygen, it's -2. Every time I have chlorine, it's -1. So my anion charge never, ever changes. Okay, so these are a couple things that we know going into this, okay? So let's look at the steps here. If you need to pause the video and copy them down, feel free to do so, but I'm going to talk through this. All right, so I have 5 steps, okay? The first thing is I draw out a T chart, and I'm going to show you what that means. I then am going to write out the chemical symbols for each element, including my subscripts. I then will calculate the overall charge of the anion side, then calculate the charge of the cation side to tell me what my Roman numeral is, and then write my compound using the following system: cation name, Roman numeral charge, anion name, and with "ide." All right, so let's look at what I mean by this because it makes a lot more sense when we do it out overall, right? So I have this formula here, Fe2O3, okay? Step 1 is to draw a T chart. This is what my T chart looks like here, right? It literally looks like a T, and it's in a chart, hence the name T chart, right? So that's step 1 every single time, okay? And we only do this if I have a transition metal, and I know that because Fe is in that group 3 to 12, okay? Step 2 says to write out my chemical symbols for each element, including my subscripts, right? So Fe2 goes on this side, O3 goes on this side, okay? Step 3 says to calculate the charge of the anion, meaning the overall charge, right? And so what I do is I take what my normal charge for O would be, right? And I know O is always -2. And in this case, I have 3 oxygens. So I need to take that -2, multiply it by 3. And so my overall charge of my anion for this compound is going to be -6. Okay, so my overall charge is -6. Okay. And that's going to help me figure out my charge for my Fe2 because remember we said that it has to be neutral, right? My Fe2O3 is overall neutral, meaning that whatever the charge of my anion is, my charge of my cation has to be the same but opposite, right? They have to cancel each other out. So if I have -6 on this side, in order to have it be neutral, it has to be a positive 6 on this side, right? Because 6 minus 6 is 0, so I now have a neutral compound. All right, and this 6 is going to help us figure out what my Roman numeral will be, okay? How I do that, right, is the same setup here, right? I take whatever my charge is, right, similar to the -2 on this side. I don't know my charge, so I'm setting it equal to x, okay? Then I take however many of my ion I have, right? In this case, it was 3. In this case, I'm going to have 2. And I'm going to set it equal to my overall charge of 6, right? And so when I solve that out, right, all I do is I solve for x, right? So x times 2 equals 6. I can divide both sides by 2, and I get x equals 3, okay? That x value is my Roman numeral. That's my charge, right? So for this example, Fe2O3, Fe has a charge of 3 plus. Okay, so I just calculated the charge. So when I write that as a name, I followed this system, right? My cation name, if I look on my periodic table, Fe is iron. I have a Roman numeral charge of 3, so I put the Roman numeral 3. And then I name my anion with oxygen, but I change oxygen to oxide. Okay, so the only difference with this, okay, the only difference with this from what we learned is now I'm adding that Roman numeral in to tell me that it's a transition metal and I have a charge of 3, okay? Let's look at our next example of SnO3, right? Same thing, draw out my T-chart, right? Write out my chemical symbols, including subscripts, so I have SnO3, right? Step 3 says to calculate my overall charge of my anion, okay? And so remember, first thing I come first is my normal charge of my atom or my ion, which is O, is always -2. I then multiply it by how many total oxygens I have. So I have 3, so I have an overall charge of -6 here, right? I then have to remember, right, that whatever this charge is, it has to be equal and opposite on this side, right? So -6 and 6 cancel each other out. And then I put in the rest of my equation here, right? I don't know what my charge is. I have 1 Sn, and I set it equal to 6. And when I solve for x, I get 6. And 6 is my charge, right? And so I have to put that charge as a Roman numeral. And so when I put my name, right, when I look on my periodic table, I have Sn is tin. My charge is 6 plus, so I have to put my Roman numeral 6. And then I know oxygen is oxide. All right. So take a minute, pause the video, and complete these 4, right? So give me the name for each of these compounds, including their Roman numerals, because they are considered transition metals. Once you are done, come back, and then we will finish up. All right, so now that you guys have done your you've done your practice, right? I should say your 4 practice, not your 2 practice, but your 4 practice. I want you now to complete your summary, right? Answering the following questions. I want you to know how to do these things. So how can you name ionic compounds if you have transition metals? How can I determine the charge, right, if I'm given the name? And how can I use that name to predict the formula, right? So everything that we've done today, I want you to summarize. And once you have done that, you're going to come back to the video so you can pause it. All right, now that your note sheet should be completely completed, including your summary, you are now going to go into independent practice. So I want you to do your practice worksheets, okay? If you have questions, comments, concerns, come talk to me, all right? And then once you feel ready, complete your Mastery Connect quiz. The code is on Google Classroom, all right? So that is it for today.